So I wanted to be able to talk to you today about the tunnel detection LRBAA topic. Thank you for joining us as we kick off the second season of LRBAA today. Our first episode, like I said, will be on the tunnel detection topic. The LRBAA is a way that DHS S&T, or Department of Homeland Security Science and Technology Directorate, is able to seek unique solutions from industry and academia to help solve gaps and seek solutions for our mission areas. The topics are high level and broad, broader than you'd see on most BAAs. The topics that we will have out there for the life of the 5-year BAA can be, new ones can be posted, old ones can be taken down over that lifetime. They are long range, as in LRBAA. So we do keep them up for a period, usually of about 1 year at least. So they'll usually stay up for, when we post them on the annual solicitation or announcement, they'll usually stay up for about a year, sometimes longer, sometimes they'll get tweaked. There is no due date for your initial submission. However, as I said, they can be taken down. So just keep that in mind as we go forward. So I want to talk to you a little bit about what the process is. So when I say there's no initial due date for initial submission, we're looking at high level topics. And because of that, we've developed a 3-step process to make sure that we're not throwing people straight into a full development of a proposal that can be time consuming and costly for many reasons. So the first step in the LRBAA submission process is called industry engagement. And this is going to be a 3-page white paper and a quad chart. And if you have a technology that is at TRL 4 or above, you can also include an optional non-professional video. The 3-page white paper and quad chart will be reviewed internally by the DHS peer review process, and you'll get a recommendation of whether or not to proceed to step 2. Step 2 is called virtual pitch. So if you're recommended to go forward to virtual pitch, you'll get an opportunity to develop 12 slides and have 20 minutes to present on your technology solution proposal. So in that, after the 20 minutes, the government will confer for 10 minutes, and then they'll come back to you and ask you some questions. We won't be able to provide you guidance or tell you how to do anything with your approach, but we will have the opportunity to ask questions. I always recommend folks pay attention to those questions, because although we can't tell you what to do, it's often a key element that we're concerned about and may not have found addressed in your proposal, or may be looking for further clarification. If after the virtual pitch there's interest in a full proposal, then you'll be recommended to move to step 3, which is the written proposal. That'll be 25 pages. And at this point, we're saying, okay, well, there's a really good chance that we're interested in pursuing this. It's not a guarantee. So again, if you've been recommended, make sure you pay attention to what happened in the virtual pitch, what the discussion was, and what elements you think that you may need to address fully in your written proposal. So, and then the goal, of course, is for us to be able to get to an award. I think that the structure of this is great, because there's often times where I go out and I'm talking to industry and they say, hey, I'd really like to talk to somebody about an idea that I have. And the LRBAA, because we have 23 topics out there right now that are broad, offers a great opportunity that there's a place where you can submit your idea. And again, this is a place for you to submit your idea. So sometimes I'll get the question from folks of, how do I talk to somebody to see if there's interest in my idea? The good news is that's the way the process is structured already. So if you have an idea that you believe that would fit a mission area for DHS, look at our LRBAA topics, see if there's one for which it fits, and then submit a 3-page white paper in your quad chart, and it will be sure to get in front of the relevant folks at DHS S&T. So as promised, we're going to be talking more specifically about the tunnel detection topic today. So I'd like to take an opportunity to bring in a couple folks that know way more than me about tunnel detection, which is not difficult to do, and introduce Carl Bess from DHS S&T also. Carl, can you introduce yourself and let us know a little bit about your role and the DHS level scope of tunnel detection.
Yes, absolutely. Thanks, Dusty, and good afternoon, everyone. I'm Carl Bess, Program Manager in the Office of Mission and Capability Support that is within DHS's Science and Technology Directorate. My job is to manage cost, schedule, and scope, as well as lead a matrix team that collectively provides research and development for programs and projects that support our component customers. Tunnel detection is nested in the Air, Land, and Port of Entry Security Program, which develops and transitions technical capabilities that strengthen the security of our national airspace and land border by detecting and preventing the flow of illicit goods and people while facilitating and safeguarding lawful trade and travel. Clandestine tunnels have existed around the world since the Roman siege of Ambracia in 189 BCE, and we still see them in use today in the Near and Middle East, as well as the continental United States. With nearly 2,000 miles of land border between Mexico and the US, roughly 190 illicit cross-border tunnel attempts have been identified since the first was discovered around 1990. The purpose of these tunnels along our southwest border is to smuggle drugs or humans, or even potentially support terrorist activities. The types of tunnels encountered by our component customers are grouped into three categories: rudimentary, interconnecting, and sophisticated. Rudimentary tunnels cover a short distance, usually without shoring, machinery, electrical power, or ventilation, and the entrance is usually in the open air or concealed by something as simple as a piece of plywood. Interconnecting tunnels connect existing underground infrastructure using at least one purpose-built section. Exits are usually in underground infrastructure and can be as simple as a cutout in a corrugated drain pipe. Once in the United States, users can navigate through the interconnecting tunnels using multiple exits as far as a mile from the border. And the last category is sophisticated tunnels. And as the name suggests, these are elaborately constructed with shoring, ventilation, electricity, water pumps, and sometimes even rail tracks that span a long distance. The entry and exit points of sophisticated tunnels are often located within homes and warehouses. Even if they're only open for a short period, they can allow traffickers to move massive amounts of drugs, humans, currency, and firearms back and forth between Mexico and the United States. Regardless of the level of sophistication, these tunnel types represent the determination, expense, and time-consuming efforts transnational criminal organizations will undertake to facilitate cross-border smuggling. Back to you, Dusty.
Thank you. I'm guessing at the price of plywood nowadays, there's not a whole lot of them that are being concealed that way. The plywood's probably getting taken, but so maybe that'll help us. I don't know. But so thank you very much for that description. I'd also like to bring in one of our colleagues, Dr. Jaime Hinkafy. Jaime, can you also introduce yourself and tell us about your role at DHS S&T with relation to tunnel detection?
Thank you very much, Dusty. It's a pleasure to be here. Again, my name is Jaime Hinkafy. I'm a geophysicist assigned to the S&T Technology Centers Division. I had the opportunity to work with oil and gas, archaeology, construction, and geotechnical engineering. In regards to the S&T Technology Centers, they provide with subject matter experts in technology developers for program-specific support. Mainly, the tech centers provide with a centralized suite of technical knowledge and support services. Those are individually tailored to the S&T program needs. So my role as a geophysicist will be to support the tunnel detection program in regards to systems that can use geophysical principles and specialized technologies to search underneath surfaces and find the objects of interest. Tunnel detection is a perfect example of the application of near surface geophysical methods. Back to you, Dusty.
Thank you. So I want to follow up that with kind of helping folks understand, for those of you not familiar with the way DHS is structured, S&T Science and Technology performs many of the research and development activities for support for the other operational components within DHS. So I wanted to kind of talk about how does S&T specifically support tunnel detection? There's a lot of stuff going on, of course, within the operational components that science and technology does not touch on. So what is our place in the tunnel detection part of the mission?
Sure. The number one goal of the Science and Technology Directorate is to build trusted relationships with our component customers that support the delivery and adoption of mission critical solutions. We do this through regular strategic engagement to clearly understand their missions, operations, priorities, and more importantly, their capability gaps. After analyzing and defining solution approaches, consensus is reached between the stakeholders and project planning then begins. As part of Science and Technology's R&D capability, we have a robust systems engineering office that includes our subject matter experts, test and evaluation, and tech scouting, to name a few. We also have very, very strong partnerships with academia, our national labs, Silicon Valley, and of course, our industry partners, which manages the LRBAA program.
Thank you. Jaime, did you have anything to add?
That's great, thank you.
Great job, Carl. Didn't have to add. And by the way, you guys can keep your cameras on. I feel like you're disappearing into tunnels. Looking at this, of course, and why we're here today is we have also, as well as a part of the mission of S&T and how we're working on tunnel detection, is we have an LRBAA topic. So how does the LRBAA topic fit into the work that we're currently conducting and pursuing at S&T in our quest for support to the components?
Sure. What we're looking for are innovative, non-invasive, and minimally disruptive sensors and systems that can detect illicit activities. And hold on one second. My screen is, oh, here we go.
Oh, yay, technology.
Sorry about that, everyone. But we use these sensors and systems to locate and detect clandestine and unknown subterranean tunnels and other subterranean threats. We sometimes use RFAs for short-term needs, and those requests are often constructed with a particular solution in mind, or at least pointing to a current technology already in use. On the other hand, the LRBAA process provides us with an over-the-horizon look, a solution or technology that we may not have previously considered or totally overlooked. With that in mind, we still owe it to you to provide some broad categories that may help. And as the slide shows, our focus is on multimodal systems, including mobile, surface systems, portable solutions, and sub-T tracking and mapping systems. One thing we've noticed in research reports and even some proposals is the temptation to imagine tunnel detection solutions in a stable or benign environment. The more realistic context we're looking for is tunnel detection in an urban environment with a high level of structural clutter, concrete and asphalt, and just as important, noise clutter. We've all seen this on television and in the movies where clandestine tunnel digging is synchronized or masked by loud noises external to the operation. It could be as simple as digging a tunnel during rush hour traffic, or more orchestrated like Danny's 17th tunnel in The Great Escape with Steve McQueen, for you classic movie buffs out there. All that aside though, even though in the most pristine environments along the border, tunnel detection is still a challenging endeavor, as Jaime will explain.
Sure, yeah. Well, tunnel detection or void detection in general is a complex process that fits perfectly one of the main traits of near surface geophysics, And that's the implementation of non-destructive and non-invasive subsurface exploration methods. An example of non-invasive systems is ground-penetrating radar, which has been used in search and rescue operations in urban areas hit by earthquakes. The system is deployed on top of a very unstable rubble, and it searches for voids where potential survivors might be trapped. The thing is that ground-penetrating radar is not a standalone system. And in those situations, many other technologies and other tools are used as well. And they work together, improving the effectiveness of the operation. And the survivors have a better chance to be rescued. So this same idea applies in near-surface geophysics. Oftentimes, a single geophysical method is insufficient to clearly and accurately locate and characterize a target. So to compensate for that, we often combine 2 or 3 mutually supporting methods, and each method's strengths complements other methods' shortcomings. So each method delivers a piece of the puzzle, and all the information is processed and analyzed in order to create new relevant information that leads to decision-making. Also, those results in turn optimize the use of other resources, like, for example, they provide with better locations for boreholes and trenches. The location of those invasive methods is guided by the geophysical results, and their effectiveness is greatly increased while the operational costs are optimized and even reduced. So this combination of methods to locate and characterize the target in the subsurface is an effort that's been going on for many years. Technology advances, especially advances in detector sensitivity, is limited mostly by cost. So related technologies such as increases in computer power, more efficient data processing algorithms, implementation of artificial intelligence and machine learning, all those are tools that are being developed and deployed at a very fast pace. Putting them together with geophysics creates a very effective system that can serve the DHS in many positive ways. Back to you.
Thank you. So, you know, one of the things that I think is really neat about the ways industry partnerships at S&T works in general, but particularly, especially the LRBAA, is we're able to take in solutions from a diverse set of the industry and academia. So we're able to get perspectives that we may not have thought of internally, as was alluded to earlier. Can you talk about that in terms of what benefit you think that brings to the tunnel detection topic?
Yeah, of course. Academic research brings in the basic science. That's the necessary first step. Often science is driven by practical, everyday problems. The practical application of scientific knowledge, that's the technology itself, is what provides answers to 3 basic questions. What's the problem we want to solve? What's the question we want to answer? And what's the main challenge we need to overcome? So many companies are already working on answering those questions by applying the findings of academic research. But this is also an opportunity for younger companies that already started thinking of innovative systems integration. As mentioned before, geophysical methods' strengths complement each other. Combining geophysical systems with other related technologies has become a standard. That is the system of systems approach. And it might be interesting to have novel combinations that can address several tunnel construction categories, like the ones that Carl already mentioned. Those who are thinking of or already started developing systems that, among other things, can provide with accurate and timely information might be already ahead of the game. And I'm sure DHS will be very interested in hearing from them.
Great. And thank you again for helping to explain all that science to us in a way that's consumable to folks without the doctor, the PhD behind her name. So what I really like again is the ability to reach out to this diverse portion of industry. But at the same time, we still have to fulfill the mission. And as Carl mentioned, you know, kind of the common assumptions that can be made can actually be part of the issue of, well, yeah, anybody can detect tunnels in that clean environment or scenario. So, you know, having led us on to some of that, I'm sure that this is a much deeper, bigger set of complications. How can we help folks that are new players in this space learn more about it so they can understand if what they have to offer may be able to operate in such an environment?
Of course. Let's see, new players often have amazing ideas. However, the systems to be implemented require very high standards in terms of reliability and endurance. So they should be already beyond the proof of concept stage. And that's very important since those systems are going to be tested and they'll need to survive and deliver in areas where inclement weather and other grueling environmental conditions are present at all times. They'll need to be flexible. They need to be relatively easy to maintain. They're going to need backup capabilities as well. And something that's very important, of course, is that they must be very easy to use. So if somebody approaches a DHS person with something like, I have this great idea, well, that's great. Of course, good ideas are always welcome. But if you approach this person with something along the lines of, I've learned that you have this problem and I have a tool or a technology that can help you solve it, you will likely get that person's attention. And if you want that conversation to move forward, your systems must be already in a stage where you can perform demonstrations, and or at least you should have your system appear in technical or scientific peer-reviewed publications showing their application and reliability. Carl, you want to add something to this?
Yes, thanks, Jaime. Essentially what we're looking for is bringing in solutions at around TRL4 and transitioning them to our component customers at no higher than TRL8, with 4 being the breadboard or validation in a laboratory type environment stage, and TRL8 being an actual system completed and qualified through test and evaluation. With regard to transition, that's what it's all about. This is what we're going to put in the hands of the customer and how we get there, and it's mission focused. We talk about transition as early as phase 1 and can't emphasize enough how we have to visualize and plan for that goal from our very first discussions. Also, we don't leave the performer alone in a vacuum and wait for a prototype or system to magically appear at the end of the contract. One of our most valued partners, Test and Evaluation, will assist the performer along the way. And we plan for that up front. And they play an important part to ensure the component customer ends up with a product that's rugged, sustainable, and above all effective in an operational environment. Steve, I think you might have a slide, mission alignment. Great, thanks, Steve. This slide will guide you to the overarching strategies and underlying legislation that will provide you with a better understanding of how tunnel detection connects to safeguarding the homeland. We're going to provide these links in the chat, so don't worry about trying to copy them here, but I wanted you to see these now to give you those thoughts. Dusty?
Thank you. I think that always making sure folks have a place to start their research. Well, if they haven't heard of TRLs yet, then that's one place they can start. So TRL, technology readiness level. And, obviously TRL8, as you described it, would be far beyond what we would do at S&T. So that doesn't mean that if you have a solution that is at TRL8 for another application, but would need rework, that kind of would put it at a lower TRL for this application, and then that's something that we could fund. And I'm assuming you guys would be open to that in that scenario, Carl.
Yes, absolutely, Dustin.
Okay. So, and thank you for the resources. It's always nice to give other people homework. So one of the questions that is always at the top of folks' lists, no matter what we're talking about, no matter which vehicle, no matter which topic, is funding. And I know, Jaime, you referenced cost earlier, and cost has several different places it plays. One is in the development, and then one is kind of in the operations and maintenance and those sorts of things. But right now, what we get asked the most about is the funding thresholds for submissions to the topic. And this obviously is not something that we're able to provide a specific threshold. Can you talk about, give folks more understanding of how they should approach how they submit their offers and the funding associated with that?
Sure, will do. I probably need to mention up front an important thing is that S&T's focus is research and development and not acquisition. We will transition the technology to the component customer at a relatively mature TRL where it will merge with the component's program of record and its acquisition lifecycle. With regard to budget thresholds, what we've seen in R&D can range from an existing commercial off-the-shelf technology that requires something minimal like a algorithm tweaked or case or mechanism hardened for use in the field, something relatively inexpensive, say around under $100,000. From that, ranging all the way up to a multi-year program system development well over $1 million. The key, though, in dealing with the larger, more expensive programs is to spread that R&D funding over a few years instead of a large amount up front. For example, $500,000 a year over a 3-year period instead of a single lump sum up front of a million or more, which would dramatically lessen its chance of survival in a single budget year. So the solution here is to build out an R&D effort incrementally over a 2 or 3 year period and demonstrate a phased progress ending in transition. Now, regardless of funding amounts, we are always beholden to the taxpayer. In addition to the checks and balances that I have to manage as a program manager, is compliance with the 2017 National Defense Authorization Act, which requires us to report to Congress on the system's performance 3 years after its transition to the component customer. I mention this now because it's important to keep in mind when considering maintainability and sustainability of your system in an operational environment.
Thank you. So, as always, quick, cheap, fast, that's what we want, right?
Absolutely.
So, absolutely. So yeah, just making sure folks understand that the value of what they're bringing to the table has to be commensurate with the costs that they're proposing and that they should be realistic.
Yes.
So I know you said more than that, but just to highlight. So talked a little bit about cost. As we go through the 3-step process, if somebody submits. So the first step is going to be industry engagement, and that's going to be 3 pages of a white paper. And I caution folks, we've gotten submissions before, and a 3-page quad paper or quad chart and a 1-page white paper is not, you can't do that. It's 3-page white paper and a 1-page quad chart. 3 pages. We want to make it a low lift. At the same time, it's important for them to be able to provide the information that gets enough interest that they get invited to the virtual pitch. Can you provide some ideas, some tips or hints on how to make sure they get that information that's the key elements to getting an invitation to the virtual pitch?
Sure. Yeah, as Dusty mentioned, the first step is that industry engagement. And this is the first look we get at your technology. So make it as detailed as possible. Science and Technology, our directorate, is a matrix of scientists, engineers, and subject matter experts who thrive on problem solving and achieving viable outcomes. So you're in good company. keep in mind that we receive a lot of proposals at this stage, and with limited budgets, we are just as discriminating at this stage as the rest of the process. There's not much space in the first step, as Dusty mentioned, so be detailed, succinct, and above all, emphasize the operational capabilities of your technology. Keep in mind, these aren't science projects. They're being resourced for legitimate operational needs. Also, some proposals mention TRL at this stage. If you do this, all we ask is for an honest assessment and not inflated. As Dusty mentioned in the virtual pitch stage, there's a little more elbow room there. And that's where we start looking at schedule and affordability. It's also where we start talking about transition and even get into discussions about risk. There's that Q&A segment. And once again, although we can't help you with your proposal during this Q&A, it's a great opportunity to clarify your approach. Also, we've seen proposals at this stage that mention a third-party performer, such as a manufacturer. This is perfectly fine and understandable. However, we would like to get some clarity of your approach to this early as possible so we can keep it as an ongoing topic of discussion to avoid any scheduling delays or surprises later in the process. Dusty?
We're not opposed to surprises. We just prefer them to not be in the call.
No surprises.
No surprises. And yes, and I, you know, while I may not be able to read the proposals in an intelligent way, we have Dr. Hinkafy here with us. So do not be afraid to be too technical. He's here to help us. So, all right. So, I think we've touched on a lot of things, and be able to get some questions in from folks. So as a way to kind of wrap up this part of our webinar, can you talk about what you see as an ideal outcome in terms of having this topic out there and what you'd like to achieve, what that would look like?
I think we want solutions that are affordable and above all effective in the field. We want everyone to be as detailed as possible in your proposals and always use an operational mindset, and keeping that sync throughout the process with the customer involved. We've got a great team, stakeholders, we stay engaged, and that's how we've seen success in our program.
Great. Wonderful, great information. And I would assume, so one of the things, again, kind of touching on what I mentioned at the beginning, I'll get contacted by folks saying, hey, we want to talk to the folks that are in this field at DHS S&T and see if there's interest in our idea. Again, the way to do that is to submit the 3-page white paper. If you're like, oh, well, we have different things and they may have different abilities, you can submit more than one submission to the page. Always make sure that you're articulating how it connects and the benefit that you're seeing. So that does require some homework, again, on your part to understand what we already have, what we're using, how this may be better than what we're using. One caution though, do not send the same submission to multiple topics. So if you have an idea and you think, oh, well, this may apply to all of these 3 things, there's no way that one submission would articulate how it could apply to those different areas. So it should be tailored in terms of what research and development would be needed, how it fits in that space, things like that. So I think we're going to tell folks how to find the topic so that if they had an idea, they know how to submit something, that one last little detail. So again, we're going to put up the links into the chat, so don't feel like you have to copy down that URL there, but you're going to be going to the DHS BAA portal. You're going to click on funding opportunities, and if you see there at in the red box on the screen, there's 2 tabs. One says research areas, one says topic areas. Make sure that it's clicked such that the tab that's white says research areas. And then you're going to select securing borders under the selections there and look for topic SEC SEC border VORD 0101. And then the portal will help guide you through the submissions. If you have any technical issues using the portal, never fear, there is the email address lrbaa.admin@hq.dhs.gov. And at the beginning of that is when I'm supposed to make sure that folks get their Q&As in, but I'm pretty sure that we've gotten some questions. So yep, we've got some to ask. Fantastic. So I'm gonna take the first one and do it real quick, if you don't mind. It's, are there limitations for large, small business who can apply? And going back to, you know, my affinity for the ability to reach the diverse population, this is ability, large business, small business, academia, FFRDCs. The LRBAA is about international, domestic. It's about as broad as you can get in terms of who it's open for application. It's, the details are in the announcement, so I recommend you read it if you're some unique or unusual, rare type of organization, and you know, figure out from there if you're eligible. But I'm going to throw the next question over to the smart folks on the webinar. So how does tunnel detection relate to other initiatives being pursued by DHS?
I can take that. What we're looking for in tunnel detection is closely related to other R&D efforts in the air, land, and POE security program, or specifically sensors and other technologies designed to detect illicit activities transiting our borders. As Jaime mentioned earlier, it's a system of systems approach. So interoperability becomes an important factor in developing and integrating those new technologies. So, you know, keep that in mind. Jaime, do you have anything to add to that?
Yes, thanks. Something that Dustin mentioned a minute ago was about the different kinds of technologies that people can propose. Well, you don't necessarily have to propose a whole system. There's some, when I was in the oil and gas, there were these plug-in systems or these other companies that created certain parts of the whole system. For instance, I remember I worked some time for what they call service companies, doing the software that helps you locate the oil. So it was just that the nature of the company was that. So you don't have to propose a whole system. You can probably come in with something that is, hey, I have a piece of software that processes your data faster and better and more accurately. That's perfectly valid. So you don't have to come with a whole package, just a little thing that will fit the purpose and make you successful as well.
They don't have to reinvent the oil rig, is what you're saying, essentially, right?
There you go.
Great to know, especially for some of the smaller businesses, I'm sure. So this question is I think really interesting, and one that I wouldn't have thought to ask and probably would have made some assumptions about. So it's there's two, and they're along the same lines. Is how deep on average is a tunnel, and do we assume that every tunnel will be big enough for a human to pass through? So thoughts on the scale that we're looking at here?
Okay, I may defer to Jaime on what's in industry, but before that, I really have to say that gets into an operational area that's law enforcement sensitive, and we probably can't discuss on what we find.
Okay.
Jaime,
But so they should be looking at this from the perspective of, you know, we're looking for tunnels, and if that is large, small, deep, shallow, we want to be able to identify them, because you know, if we don't know where they are, we don't know where they are.
Absolutely.
And you know, I'm on the short side, so saying large enough for a person to pass through could be there's some wiggle room in there as well.
Sure.
I mean, did you have any?
Yeah.
Go ahead.
No, I was going to take it, Jaime, to see if you had any comments along those lines.
Yeah, it's as Carl says, it's a sensitive point, but all I can say is that your imagination as a solution provider is the limit. think of all the possibilities and try to tackle a few of them so you can have a good niche, and if you have a good solution to the issue, the folks at DHS are going to be willing to look at. So
I'd imagine that, being given the fact that, sorry to interrupt, that Carl said they've been around since 189 BC, that the uses have been pretty diverse over the years as well, and they've been used for more modern things and more remedial things throughout time. So yeah. Great. All right, so I think I've got one last question before we want to, wait a minute. No, okay, those we've answered. One last one. So you discussed the use of mobile technologies or solutions. Can you expand further? I'm not sure what that means, but I'll leave it to you guys, the ones smart in this area, to address.
Okay, I can start off with this one. We see many passive systems under development in this space and want to see more tools available to the operator in the field. And mobile detection is one of those modalities. And what we mean by mobile can be in the sense of use as well as areas of coverage. It can be anything handheld by an agent to a vehicle mounted or a towed system. However, I don't want to lead what you may have in your mind for what our audience may have in mind by being too descriptive here, because we want to keep this playing field as wide open as possible. The bottom line is that we're open to everything, provided it meets mission needs. Jaime, I don't know if you have anything to add to that.
Yeah, just to complement the idea of the size. Well, if it can be put in a backpack, that's portable. But if it can be put on a fixed aircraft or rotary wing aircraft, that's mobile as well. But mobility doesn't translate directly to coverage. You can have a small system that can cover a very big area, or you could have a large system that covers only a small area. So those things are interchangeable. So whatever your idea is, just think about how it can be deployed and how it will serve the purpose of the mission, as Carl said.
Okay, great. So I want to thank you guys for joining us today. We are going to be wrapping up here. So folks know we did record this session, so we're going to be looking at getting that posted onto YouTube once we're able to get it in the format that we need to get it into. I do want to let folks know that we are going to be moving forward on 14th of July with our data analytics LRBAA Today episode. And then on the 18th of August, we're going to be doing our Screening at Speed LRBAA Today. So we look forward to having folks join us for those as well. And again, I can't thank you enough, Carl and Jaime, for joining us and providing your insight and information to help us get to better solutions from industry and academia. Have a great day, and thanks, everybody.
Thank you. Have a great day.
Thanks, Dustin.